Okay, so let's start with today's class. Today, the first thing that we are going to talk about is constructors. So let's first discuss a particularly peculiar question. So why are constructors called constructors? So why are constructors called constructors? So as I told you, this is a peculiar question. So why do we call constructors as constructors? Why are they named so? There's simply just one reason why they are called as such. It's because it constructs value. So constructors. So the answer to this question. So this is the question. The answer to this question is it's because constructors construct values during object creation. So the reason why constructors are called constructors is because it constructs values during object creation. So that should be your answer to this question. Now, what do you mean by construct values? It's nothing but this particular set of words, construct values, means nothing but initialization. So this is equivalent to initialization. So it basically refers to the work of the constructor. So what does a constructor do? It initializes our class variables or instance variables, as you may call them. So it constructs some default values for them. These default values are predetermined. For example, for integer it's 0, for string it's null. So these predefined values, so it constructs these predefined values and it initializes the variables defined in the class. So the variables that are defined in the class have two names. So they can be called class variables. These are the variables that are defined in a class. They could be called class variables or instance variables. Now, why instance variables? Because they belong to instances. Now, what are instances? They are nothing but objects. So, an instance is equivalent to an object. So, by an object, if you remember the definition of an object, by an object we mean the instance of a class. So, the class variables, so for every object, the class variables are unique. So let's say I have declared two objects of the same class. So those two objects will have their separate versions of the class variables that were defined in the class. So before we directly jump on to constructors, let's first let's just quickly revise the concept of objects and classes. So just a quick revision of our objects and classes. So let's say I have a sample class called A. Inside I have certain variables, let's say int age, string name, Let's say I have these two variables and I have a method to input values into these variables. So I'm not writing anything inside the function, just to demonstrate the relations and connections between objects and classes. I'm just writing only this part. So if you see these two things here, they are what we meant by class variables. Why? Because they are defined inside the class. So why are they called class variables? Because they are defined in the class. Just after the class, the variables that are defined are known as class variables. They are also called instance variables. So they are also called instance variables because they are unique to the instances. So let's say I have the main method here. Let's say I have the main method public static void main. I'm not writing the whole thing. So inside the main method, I'll define obviously objects of this particular class A. So A, let's call the first object obj1 is equal to new A. Let's define one more object obj2 is equal to new A. Now I have defined just two objects, so you could define as many objects as you need. Now why are the class variables called instance variables? Because if you look at memory, obj1 will have two variables, right? So this is the object obj1. It has the object may also be referred to as an instance of the class. So this instance obj1 has two variables that are unique to it. So it does not share these variables with anybody else. It is private to this particular object. So it belongs to this particular object. So what are the two variables? The first variable will be age. The second variable will be name. So these are the two variables belonging to obj1 uniquely. So as you can see, I have two objects defined here. So there are two objects obj1, obj2. So what about obj2? What about the object, second object, the object 2? It will also have two variables, age and name, but the age and name of object 2 will be a version unique to object 2. So this particular variable and this particular variable are not the same. They will not have the same values. They are different. So the age variable of obj1 and the age variable of obj2 are two different, as in they are stored separately in memory. It's not a singular space. It's not like just there are two memory spaces called age and name and they are shared by all the objects. It's not like that. Every object creates a new block of memory where you have one part that will store the age and the other part will store the name. So if you define 100 objects, there will be 100 such blocks, each with two parts. One part will store the age and the other part will store the name of that particular object. So these class variables, they are called class variables because they are defined inside the class, but they are also called instance variables because they are unique to every instance of the class. So instances are nothing but objects, so they are unique. These variables are also called instance variables because they are unique to every object of the class, or rather every instance of the class, if you might say it like that. So the constructor, what it does is, so as you can see here, there I have not defined any constructor. But when you run this, or rather when you compile this particular program, the compiler automatically supplies a default constructor, which we are calling here. So this is the call to the default constructor. It has one single job. The only job of the constructor is to initialize these two variables. So the first variable is initialized to 0 because it is an integer data type. The second variable is initialized to null because it is of string type. So that's the job of my constructor. The only job of the constructor is to initialize variables. So whenever we define an object, we have to simultaneously call the constructor to initialize the variables to some default value. It doesn't matter what default value, to some value. So constructors are called to initialize the class variables or the instance variables to a starting value or default value. Now let's get back to constructors. So I hope the difference is clear. So why are they called class variables or instance variables? So I hope that definition is clear. Now let's get back to our constructors. So constructors are called constructors because they construct these default values that need to be initialized to the class variables. Now let us talk more about constructors. So there are certain rules for creating constructors in Java. Now let's say I'm not relying on the default constructor provided by the compiler, but I want to write my own version of the constructor. I could provide my own version of the default constructor, or I could provide my own version of a different type of constructor. So let's first take a look at the types of constructors. So we'll dive into the rules of writing a constructor a little bit later. So before that, let us take a look at the types of constructors. So there are basically of two types. The first type is called the default constructor. The second type is called the parameterized constructor. So there are basically two types of constructors. The first one is called the default constructor. So the default constructor is nothing but non-parameterized constructor. So you could also call it a non-parameterized construct. A default constructor is nothing but a constructor that does not take any arguments, whereas on the other hand, a parameterized constructor is a type of constructor which takes arguments. How and where are those arguments used? We'll get into that a bit later on, but just for now, know that there are two types of constructors. The first type is called a default constructor. So the first type is called a default constructor, or also known as the non-parameterized constructor, which is nothing but a constructor that does not take any arguments. And the second type is called a parameterized constructor, where it is the same constructor but it takes certain arguments when it is called. So we'll take a look at we'll take a detailed look at these two types of constructors, but before that, let us study the rules for writing constructors. So what are the rules for defining constructors? As the class name. So if the class is called A, the constructor will also be called A. If the class is called student, the constructor name will also be student. If the class is called program1, the constructor will also have a name program1. The cases will also match. So if program1 starts with a capital P, the constructor name will also be program1 with a capital P. So the names must be same. The class name and the constructor name must be same. That's the first rule. The second rule is the constructor will not have a return type. So the constructor will not have an explicit return type. By explicit, we mean that we do not specify a return type while defining a constructor. We could also simply write the constructor will not have a return type. Not even void. This is very important to remember. Normally, in case of functions, what happens is if the function does not return any value, we define the return type as void. But in case of constructors, it does not have that part of the, it does not have that part at all. So there is no return type part at all in case of constructors. So it can neither be any data type nor it could be void. It simply does not have a return type. Just remember it simply in that way, it does not have a return type. So we do not need to explicitly mention a return type part. So when we look at the definition, or rather the when we start writing constructors, just like functions, a constructor will also have a constructor signature, which is nothing but the first line of the constructor. Just like a function or a method has a method signature, which is nothing but the first line or the header of the method, which marks the beginning of the method. A constructor will also have a header or the first line that marks the beginning of the constructor. So that header, when compared to the header of a method, will not have the return type part. Okay, if you remember the function signature, so a function signature had these parts. So it had what do you call that? It has an access specifier. So I'm writing down the parts of a function signature. So it will have an access specifier, which determines who can access the method and who cannot. It will have a return type. It will have a name, and it will have some arguments. So these are the parts of method signature. So these are the parts of a method signature, or rather the first line of the method or the method function header that you call normally. So a function header or a method header, also known as a function signature or a method signature, has these parts. There are 4 distinct parts of the function signature or method signature. But in case of constructors, they are very much similar to methods, but there is a difference. So a constructor will have an access specifier part. It is permitted to have an access specifier, but there are some limitations. We will talk about those limitations in the third rule for defining constructors. But before that, it can have an access specifier. Barring certain access specifiers, it can have the others. It does not have a return type. As mentioned by the second rule, it does not have a return type. The name is the class name. There's one more difference. So that's the other difference. It does not have a return type, the first difference. The second difference that its name is same as the class name, which is the first rule. And it might take arguments. It's optional, but it might take arguments. So these are the parts of constructor signature, if you may call it like that, or the first line of the constructor. So I'm just calling it a constructor signature just to match it with the method signature. So if you compare the first line of a method and the first line of a constructor, these are the differences. So both of them might take access specifiers, but there are certain limitations in case of constructors. A function has a return type, whereas a constructor does not have a return type, not even void. So this is important. You must remember that not even a void return type can be used for constructors. It simply does not have this particular part. So this particular part is absent from constructors. Constructors are designed in such a way such that it does not have this part. So this whole part is missing. It does not have that part. But it has a name, but there's also a rule to the name. So the name must be similar, or not similar, rather the exact same as that of the class name. It is permitted to have certain access specifiers. There are certain rules. I'll be talking about that later. Does not have a return type, never has a return type. A constructor never will have a return type. It will have a name, but the name will be same as that of the class name. And it might or might not take arguments. Okay, so those are the differences between a method and a constructor. We'll also talk about the differences between a method and a constructor. But by just looking at a constructor and a method, you can find a lot of similarities. But the differences that will help you differentiate between a constructor and a method are these. It does not have a return type. So the main two differences are a constructor will not have a return type. A method will always have a return type. If it does not return any value, it will at least have a void return type. But the constructor will never have anything as such. It will never have a return type, not even void. The method name can be anything. It can be there's no hard and fast rule as to naming a method, but there is a hard and fast rule to name a constructor. A constructor name must always be the same as that of the class name. Okay. If you do not name a constructor, if the name of the constructor does not coincide with the name of the class, then it cannot be treated as a constructor and the compiler will give you an error. It must always have the same name as that of the class name. And just like methods, constructors might also take arguments. This brings us to the third rule, which tells us which access specifiers cannot be used with a constructor. So a Java constructor cannot be, number one, it cannot be abstract. We haven't done abstract classes. It's not in your syllabus, but just know that it cannot be abstract. You do not need to know what is an abstract, or you do not need to know the concept of abstract. Just know that constructors cannot be abstract. It cannot be defined as static. A constructor cannot be static. It cannot be abstract. So a constructor cannot be static, which means a constructor is always invoked by an object during its creation. So defining it as static will allow it to be called without an object, which is not an option. So therefore it cannot be static. Static methods can be called without, if you remember the functions of the static keyword, the very main function of static keyword was if a variable or a method is defined as static, it can be called without using an object. Static, what it does is, it helps you to just remember this particular point, that it helps you to call or rather access a method or a class variable without using an object. So since constructors are invoked when objects are created, so they are invoked by the object itself, there is no point in defining it as static. So it cannot be static. Also, it cannot be final. We have also discussed the final keyword. So it cannot be final, and it cannot be synchronized. This is again another concept that is not in your syllabus. The only things, or rather the only two words that are in your syllabus are static and final. But just know that the constructor cannot be also abstract as well as synchronized. So I'll not talk about abstract and synchronized. Just know as a fact that a Java constructor cannot be these four types. Rather, a Java constructor cannot be defined as abstract, static, final, and synchronized. As I told you, we can use access modifiers while declaring a constructor. So the access modifiers that are allowed. So let me write it down in a different ink just to differentiate it from the rest. So these are called the allowed access specifiers, which are basically allowed when you are declaring a constructor. So they are private, protected, public, and default, just like a class. Class has multiple others. They can be defined as these also, but um, private, public, protected, default. These are the access modifiers that are allowed while declaring constructors. Remember these rules. The first rule is that the constructor must have the same name as the class name. The second rule is that the constructor will never have a return type, not even void. The third rule, the first and second rules are the most important. The third rule is not so much. Rather, the third one, you normally do not use access specifiers um, while declaring constructors. Compare or depending on the scope of your syllabus, you would not be using any access specifiers. But just to let you know, for your knowledge, Java constructor cannot be abstract, static, final, and synchronized. But the access specifiers that are allowed are private, public, protected, and default. These four are allowed, whereas the top four, abstract, static, final, and synchronized, are not allowed. Okay. Remember these three rules. The first rule and the second rule are the most important ones. The third rule is optional, but it's good to know if they ask you something on this. So it's better to know. But the first and second rule is a must. You must remember them. Those are the basic rules for defining a constructor. So those are all the rules. Now, as we talked about a while before, there are basically two types of constructors. So the first one is called a default constructor, which does not take any arguments, and the second one is called a parameterized constructor. So we shall dive into those two variations. So now let's take a look at the default constructor first. So let us first take a look at what are default constructors. So the syntax of a default constructor is pretty simple. Class name, which is the name of the constructor, no arguments, and nothing inside. So that's the general syntax of a default constructor. Now let's take a look at an example with a class. So let's say again we take the example class A. There is an integer variable age, there is a string variable called name, and if I want to write a default constructor, the constructor name will be a. It does not have any return type, also does not take any arguments, so this is the default constructor, and that's it. So this is one way of writing the default constructor, or rather this is the constructor that the compiler provides you with. So when you do not define a constructor, this is the default constructor that you will be getting from the compiler. So let's say you do not provide a constructor. So let's say I have a class which has certain things written inside, but you do not provide a constructor to this class, as in you have not explicitly by yourself written a constructor. What happens? The compiler, during compilation, does this particular thing. So you have class A, inside you will have a default constructor, and the class ends there. So you provide the compiler with a class that does not have a constructor written by you. The compiler will provide a default constructor, which is nothing but the constructor here mentioned here. So this is the constructor that the compiler will provide. It is one form of default constructor provided by the compiler. So when you are writing programs, you can obviously write a default constructor like this. This particular constructor automatically initializes the variables to their default values. So each data type has a default value. Writing this particular constructor on your own will do the same thing as providing as if it is provided by the compiler. So if you write it on your own, it will do the same thing. Even if you do not write it on your own, the compiler will provide one such constructor and it will do the same job. So writing nothing inside the constructor basically means that it is a default so this is a default constructor depending on two things. It does not take any arguments, which is the most important part, and it does not have anything inside the curly braces. So looking at these two features, you can say that this is a default constructor, and the default constructor automatically initializes every variable depending on its data type. So it's internally hardwired to do that job. How it does it, you do not need to get yourself involved with. So if you write it like this, this is the form of a default constructor. So the general syntax is this. This is the general syntax. The class name, as you can see here, we have the class name followed by empty brackets, which does not take any arguments, and then an opening curly brace and a closing curly brace. So that will do your job for initialization. Now you can try something to see exactly what happens, or rather what a default constructor does. So you could try a piece of code which is as follows. So you could write this piece of code and run it, and it will be clear what exactly is done by the default constructor. So let's say I have two variables, string name and int age. Let's say I am writing my own default constructor, as well as I am writing a display method to display the values of the default constructor. rather the values that are stored in the variable name and age. So I just want to display the default values that have been stored in name and age. So I'll do name, I'll print a space, and I'll print the value stored in age. So the display method simply displays the default values that have been stored in the class variables. Then I'll have the main method. So I'm not writing the whole thing, you know how to write the main method. Inside the main method, I'll define an object. Here, as you can see, I'm calling my own default constructor. So this is the default constructor that I have. So this is my default constructor. When I'm creating an object, I'm calling my default constructor that I have written. So the compiler, since I've written it already on my own, the compiler does not provide its own version. It uses my version. So the compiler now uses my version of the constructor, the default constructor, instead of providing its own. And this particular default constructor is called here when I'm creating the object. Now, if I call the display method, it will simply display the values that were initialized to these variables by the constructor. So the display method basically displays the values that were initialized when the object was created. So the constructor will initialize the values. So we can use the display method to check what values have been initialized in the variables during the creation of an object when the constructor was called. This, so this is the end of main, this is the end of the class. This will give me an output like this. So first I have name. The default value of string is null, so I'll have null followed by a space and then 0. These are the outputs that I'll get because these are the default values that have been stored in name and age by the constructor. As soon as I create an object and call the constructor, these two values are stored in name and age respectively. So the name variable has null stored in it by the constructor, or rather the name is initialized to null, and the variable age is initialized to 0. All is done by the constructor. So it initializes the variables to default values. So this default constructor is optional, as we have been treating it in all our string programs. So you can either write it on your own like this, doesn't matter. You could also leave it for the compiler to provide you with one. You could either write it on your own. This is the format of the default constructor. It does not take any arguments. It does not have anything inside. Similar. So notice the similarities between this constructor and the method. So the constructor here has a name, but the name will be same as that of the class name, whereas a method can have any name. Method has a return type, constructor does not have any. A method will have something inside. The default constructor does not have anything inside. It will not have any arguments. It will not have anything defined inside the curly braces. Okay, that's your default constructor. Just the class name, opening and closing brackets, and opening and curly braces. That defines a default constructor for you. It's optional, you could provide it on your own just like I have written it here on my own, or you could leave it up to the compiler to provide a default constructor on its own. Okay, so there's nothing else uh, to know about a default constructor. It's simply the class name. It is just simply this particular method of definition. So default constructor is just the class name with no arguments and empty curly braces. Now let us take a look at the parameterized constructor. So parameterized constructor, as the name suggests, will take a certain number of parameters. We do not call the parameters arguments because um, arguments and parameters are different in case of Java. So arguments are the actual values that are passed during the function call. Parameters are the variables where those arguments are received or stored. So parameterized constructor will have parameters. So how what is the general definition of a parameterized constructor? Here. So it will have a name which is nothing but the class name. So it will have certain parameters. So parameter 1, parameter 2, and so on. It could have any number of parameters. Inside, it will initialize the class variables. Let's call it class variable, class var for short. So class variable 1 is initialized to parameter 1. That's the general way of doing it. Class variable 2 is initialized to parameter 2, and so on. So if I might write a default, rather general syntax of a parameterized constructor. So as constructors do have a name which is same as the class name. So the class name here followed by a set of parameters. I'm not calling them arguments because arguments and parameters are obviously different in case of Java. Arguments are the actual values that are being passed. So inside main, so let's say I have public static void main. Inside main, let's say when I'm creating an object, class name obj is equal to new class name. Here, instead of empty brackets, I'll just have arguments. So I'll have argument 1, argument 2, and so on. Okay, just to differentiate between parameters and arguments. So when I'm creating the object and the constructor is being called, the values that are being passed in the brackets of the constructor. When I'm calling the constructor, obviously, remember, when I'm creating the object, the constructor needs to be called. When I'm calling the constructor, I'm passing certain values in the constructor brackets. Those values are called arguments. These values being passed, just like a function call, must be received into variables in the function header. If you remember the function, how functions work, we pass values. These values are received into variables. The values are called arguments. The variables are called parameters. Similar to functions. So the argument 1 is received in parameter 1, the argument 2 is received in parameter 2, and so on. These parameters are then used to initialize the class variables. So the first class variable is initialized to parameter 1. This particular order need not be followed strictly, but it's norm. So the first parameter is usually initialized to the first class variable. The second parameter is usually initialized to the second class variable, and so on. Okay. That is the general syntax of a parameterized constructor. We'll take a look at the example of a class to get more clarification. So let's take a look at a class, an actual class. So again, remember our class called A. Inside we had string name, int age. So we had two variables. Now instead of defining a default constructor, I'm going to write a parameterized constructor. So this constructor will have parameters. Let's call it, so string n, int a. It could be any, so the variable names can be anything. Just like you have rules for defining variables, you can follow those rules here. For the time being, make sure that the class variable names and the parameter variable names do not match. For the time being, make sure that they do not, that they are not the same. If they are same, it gives rise to a new problem which can be dealt in another way. But just because, for the time being, just do not use the same name for the variables. The class name variable and the parameter variables, for the time being, make sure they are different. They can be same. There is no rule prohibiting them from being same. They can be same, but that needs to be dealt in a different way. We'll talk about that in the next class, not in today's class. Let's see. For the time being, just make sure the class variable names and parameter variable names are different for now. Inside the constructor, we will do name is equal to n. So the first, so just matching the data types. So the first one is a string parameter which will correspond to the string name. So name is initialized to n and age is initialized to a. So that's your constructor, the parameterized constructor. Let's say there are certain functions. I'm not writing the functions, we are concerned about constructors only. So this is the parameterized constructor. Now let's take a look at the main function. Public static void main, and there is string args. I'm not writing it. So inside I'll define an object of class A. So a obj is equal to new a. Now instead of so let's do it with empty brackets, and let's create one more object. Let's call it obj2 new a. Now let us pass certain arguments. Let's say I do this, and let me write it down in a single line. I hope it will fit there itself. Notice the difference between the two object creations. The first one calls the default constructor, which is automatically, if you do not write one on your own, it's automatically provided by the compiler. So even though you write a parameterized constructor, the compiler always provides a default constructor if the default constructor is not written by you. Okay, that's a point to remember. So if you do not write the default constructor on your own, the compiler will always provide a default constructor for these types of cases when you do not pass any arguments and such. Okay. But when you are calling the parameterized constructor, you must make sure you always pass two arguments, because there is only one constructor, parameterized constructor, with this particular format. So it takes two parameters. This parameterized constructor has two parameters. Therefore, when you call the parameterized constructor, you must pass two arguments. Simple rules of function call and all that things. So function calls and method calls have this particular rule. The number of parameters must match the number of arguments, otherwise it gives you an error. Same rules are followed here. The number of parameters in the parameterized constructor must match the number of arguments when calling the parameterized constructor. As you can see, there are two parameters, there are two arguments. Here, first I'm passing the name as an argument, which is this is an actual value, therefore it is called an argument. So I'm passing the name, I'm passing the age, which is being received in these two variables, n and a. Finally, inside the parameterized constructor, I'm initializing the variable of object2, the name variable of object2 to n, which is Ritesh, and the age variable of object2 to 16. But in case of the first object, since it is being initialized by the default constructor, so I'm just writing the values. So obj name will be null, obj, let me write it in this way. So if I do SOPLN just to check what values have been initialized, so I'll have two SOPLN statements. Let's first do it for the first object, obj.name, and the second variable of the first object, obj.age. If you do this, what do you think the output will be? If you do this, you are printing the value stored in the name part of the first object and the age part of the first object. What do you think will happen? What type of output will you get? Pretty simple. Take a look at the first object when it has been defined. Take a look at what type of constructor has been called. In case of the first object, as you can see, the default constructor was invoked. Therefore, the name part and the age part of the first object will have the default values initialized to them. So therefore, these two statements will give me an output null and 0, which are the default values for string and integer. Pretty simple, right? Since the default constructor is being invoked in case of the first object, I get default values when the objects are initialized, when the object is initialized, or rather when the object variables are initialized, these two variables for the object, we get null and 0. On the other hand, if we do object2.name and object2.age, once more take a look at the board. In case of the definition for object2, take a look at the line where object2 has been defined. So in that definition, as you can see, not the default constructor, but the parameterized constructor is being invoked. Since the parameterized constructor is being invoked, we'll go and take a look at the left hand side of the board. So on the left hand side, as you can see, the parameterized constructor initializes the object variables to the parameters received. So as you can see in the object call, rather the object definition where the constructor is invoked, the parameterized constructor, I'm passing Ritesh and 16 as arguments, which will be now the outputs of object2 variables. So the first line of SOPLN will give me Ritesh, the second line will give me 16. Okay. So if the default constructor is called, we get default values. If a parameterized constructor is called, we get the arguments that have been passed to the parameterized constructor. So as you can see, we had passed two arguments. These two arguments were initialized to the variables. When the parameterized constructor is called for object 2, so here again, object 2, I'm calling the parameterized constructor for object 2. Here, as you can see, I'm calling the default constructor for object or obj. Here I'm calling the parameterized constructor for obj2. In the beginning, if you remember, I had told you each object has its own set of variables. Therefore, since obj2 has been called with the parameterized constructor, it will have the argument values as stored in the in its variables. Whereas in the first case, in case of the first object, since I'm calling the default constructor, the values stored in the variables are default values. That is the difference. That's the difference between a default constructor call and a parameterized constructor call. Okay. Let's say you want to initialize the object variables to custom values. Let's say by default, so there's no way, so when you are writing a program, there's no way to actually know the name and age of a person. So instead of providing a name and age, you will provide some custom default value. So let's say you do not like the values null and 0 provided by the default constructor, and you want it something to be, you want a customized value, something of your choice. What you will do is, you'll just provide xyz instead of null and 0, or let's say a negative value. I want to provide a negative value, not 0. 0 is the default value, so let's say I want to provide minus 99. I could provide anything. The main idea is, using parameterized constructor, I can initialize my object variables to custom values that I choose, not the ones that are provided by default. Values that I am going to choose according to my liking. So I can use the parameterized constructor to initialize the object variables to custom values. That's the main use of a parameterized constructor. Let's say object 2 does not take any inputs, so I've forgotten to call the input, or rather I do not call the input method for object 2. It will by default have xyz and minus 99 as default. Okay, instead of null and 0, it will have xyz and minus 99. So parameterized constructors are basically used to initialize object variables or instance variables to custom values of user choice. So not user choice, rather the programmer's choice. So why do we use a parameterized constructor? Because some programmer might want to, or rather some user might want some other default values apart from the ones provided by the programming language. So why do we use parameterized constructors? Why use parameterized constructors? That's one more question. Why use parameterized constructors? The answer would be to assign customized default values to instance variables. Why use parameterized constructors? The answer is simple: to assign customized default values to instance variables. If we do not want customized default values, we can always rely on the default constructor. But if we want customized default values such as xyz in place of null or minus 99 in place of 0 for integers, we can use a parameterized constructor. Okay, remember, just compare it to a video game. So in a video game, when you first start, you installed a video game. When you first start the video game, the keyboard and mouse has certain default values. The keyboard inputs and the mouse has certain default keys assigned to them. So let's say moving forward has the default key W, moving backward has the default key S. Let's say the fire button is by default assigned to the left mouse button. Those default values are set in the game code using parameterized constructors. So once you create a user, once you create a profile of the character that you want to play with, that character will have certain default values. Even for the character itself, how the character looks, the appearance of the character. Let's say the character wears a white shirt and a white short, or let's say a white t-shirt and a white short by default. Those default values are actually, done using these parameterized constructors. Those are custom default values, right? So if you leave it to the compiler, then in there it might have nothing. So the character might, who knows, turn up naked. So parameterized constructors are used to assign default values of your choice. So in case, I'm giving the example of a game because it's much more relatable. So when you install a game for the first time, the character has certain default clothes, the keyboard has certain default keys assigned to movements and stuff, the mouse has certain default keys assigned to fire and all those things. So those default values are custom values which are initialized using a parameterized constructor. Okay, how it's done, you do not need to go into the details, but that's the real world use of parameterized constructors. You want certain custom default values, you use a parameterized constructor. Now the next thing that we are going to talk about, so I hope the default and parameterized constructor is clear, and when and how we use it and why we use it. Now let us get into some advanced topics. So there's just one thing that you need to know. Just like as I told you, there are a lot of similarities between functions and constructors. Just like we can overload functions, we can also overload constructors. So I hope you remember function overloading. So there's also something called constructor overloading. So what was function overloading? If you remember, function overloading was same function name but doing different things. So multiple functions having the same function name but doing different things when they are called. Similarly, constructor overloading works in a similar way, except in case of functions, we could differentiate using the return type as well as the number of arguments and the type of arguments. In case of constructors, since they do not have any return type, therefore the only way to differentiate is by the type and the number of arguments. So constructor overloading, the definition is the same as that of method overloading. Different, put it simply, different constructors, let's not call it different, let's say multiple constructors, which is a more appropriate word. So multiple constructors with same name. Again, this same name part is redundant because constructors will always have the class name, right? So if you write more than one constructor, it will obviously have the same name. By hard and fast rule, it will always have the same name because the constructor name is same as that of the class name. So if you write more than one constructor, it will always have the same name as that of the class name, therefore the name is always same. The only way to differentiate between which constructor will be called and which will be not, as in how the compiler differentiates is, so let's this poses another question: how are overloaded constructors differentiated by the compiler? So the compiler must have a way to differentiate which constructor you are trying to call when defining objects. How does it do that? How are overloaded constructors differentiated by the compiler? The answer is looking at the number and type of the parameters. So how does it differentiate? It looks at the number, as in the number of parameters that the parameterized constructor or non-parameterized constructor. So non-parameterized is basically boils down to the default constructor. So looking at the number of parameters or by the type of parameters, as in the data type of the variables, which are the parameters of the constructor. Looking at these two things, the compiler differentiates between multiple constructors. Okay. So if I have more than one constructor in my program, the compiler will take a look at the number and type of arguments. Depending on that, it will, try to differentiate between which constructor I am calling at object creation. So let's take an example of constructor overloading. So let's take a look at the program code example of constructor overloading. Let's say we take the same class A. Let's say we have the same variables, string name and int age. So let's say we are taking the same class. We are going to write two constructors. So we are overloading the constructors. So we'll write one constructor with a single parameter or taking a single argument, and we'll write one more constructor which takes two arguments. Let's say I have these two constructors. The first constructor takes a single argument, therefore it has a single parameter. The second constructor takes two arguments, therefore it has two parameters. Now let's take a look at the main function. Inside the main function, let's say we are creating objects. First object is called obj1. And we just make a call to the first constructor type. So for the first object we call the first constructor. For the second object we call the second type of constructor. Notice the differences. So how does the compiler know which constructor to call? It differentiates using the number of arguments in this case, because the first constructor has a parameter called string s. The second constructor also has a parameter called string s. Both the names of the parameter variables are same. Therefore, it differentiates using the number of arguments that the parameters take. So the first one takes a single argument, the second one takes two arguments. Now take a look at the object creation on the right hand side. So in case of object creation, it's pretty clear that the first object invokes the constructor with a single argument. The second object invokes the constructor with two arguments. Right. Let's say I have one more object. Which simply calls the default constructor with no arguments. So all three objects are initialized in different ways. The first object is initialized by the constructor that takes a single argument, which is this particular constructor. So the first object is initialized by the first constructor. The second object is initialized by the constructor which takes two arguments, because I'm passing two arguments to the constructor call there. The third object, however, is initialized by the default constructor. Since I have not written a default constructor, the compiler provides me with a default constructor. So the default constructor will look something like this. So that is provided by the compiler. So the third object call will use the default constructor. So this is the default constructor. By default, if you do not pass any arguments, or if so if you do not pass any arguments, so the default constructor is called, which does not take any arguments. If you call the constructor with one argument, then the constructor defined with one parameter is called. If you call the constructor or invoke the constructor with two arguments, the constructor correspondingly with two parameters is being called. So that's simply how parameterized constructors on overloading, that's how it works. Depending on the number of arguments that you are passing and the type of arguments that you are passing, the corresponding constructor will be invoked, or rather the corresponding constructor in the class will be used. Okay, so that is how constructors are overloaded. Overloading constructors basically works with parameterized ones. So parameterized constructors are only the ones that are overloaded. The default constructor always remains the same. So there's one thing that I don't know if you have noticed or not. So here, in case of the constructor with a single parameter, I'm just passing a single value, whereas the object will definitely on creation have two parts, the name part and the age part. But I'm just passing the name part, default value for the name part. What happens to the age part? Any guesses? Just let me repeat my question once more. Take a look at the first object creation, the first line. Object 1 is created using a call to the single parameter constructor, where the parameter takes a single argument, but the object does not have just a single variable. Since it is an object of this class, it will definitely always have all the variables as its parts. So even if I'm not passing an argument here, it most definitely has an age part. Does not mean that object 1 will not have an age part. It will obviously have two parts. So the number of variables that an object has always depends on the number of class variables that have been defined. In case of object 1, object 2, object 3, all of them have two parts or two variables. The name variable and the age variable. All of them will have their separate name and age variables. But in case of object 1, as you can see, I have only passed a single default value to the constructor, thereby calling the first constructor, which takes a single parameter. Name is initialized fine. Name is initialized to XYZ. What about age? What about the variable age? I'm not passing any arguments. So what do you think the value of age will be? So what do you think the value of age is going to be? It will obviously be initialized to its default value by the default constructor. So if any arguments are missing, so if the number of arguments does not match the number of variables, as in case of the first constructor call, the number of arguments, here you can see there's just one argument, but the number of variables are two. So the second variable, a value for the second variable is not provided, a custom value is not provided. That does not mean that the second value is not initialized. The second value is also initialized by the default constructor. So any custom values that you pass are initialized to the corresponding variables. Let's say you are missing one value, but you have the constructor defined. So if you do not have a constructor defined that takes one parameter, then it will give you an error. But if you have, since you can see that I'm not initializing age here, so age is by default initialized by the default constructor. Automatically it's done. Here I'm just only concerned by the argument that is being passed. So that is the only thing that I'm initializing it to name. The second variable age is by default initialized to 0. You might be wondering how it works, right? How I'm only passing just one argument and both of the variables are getting initialized. The first one to the custom value, the second one to a default value. How is it being done? It's pretty simple. Whenever you create an object, be it using a default constructor, just think about it in this way, just so that it's easier for you to understand. Whenever an object is created, the default constructor is always called. Just remember it in that way. If the default constructor is always called, name is initialized to null, age is initialized to 0. Now let's come back to the parameterized constructor. Here I am passing a parameter. So the default value null that was stored in name of object 1 has been replaced by the parameter being passed, or the argument being passed, which is xyz. So null is replaced by xyz, whereas the default value age equal to 0, which was initialized by the default constructor, remains as it is because I'm not passing any arguments there. Simply remember that whenever you create an object, it will always call the default constructor apart from calling the parameterized constructor. So just to remember it in that way. It might not happen actually that way, in that particular order. So it happens in a different way. So it does not happen in as I told you. So it might happen, it might be done like this. So let's not bother with how it happens. So just don't go into the details. Even if you pass just one custom argument, both the variables are initialized. Even when you are passing just one value, both the variables are initialized. Just remember it in that way. How are they initialized is not important, but all the class variables are initialized no matter how many arguments you are passing. If the number of arguments is less, doesn't matter. The other variables will also be initialized to default values. So the arguments that you are passing will be initialized to their respective variables. Let's say you are missing an argument, it will just initialize it to a default value. Okay. So that is how constructor overloading works. You call the different types of constructors, and depending on the number and type of arguments, the corresponding constructor is invoked. Just like if you take a real world example for overloaded constructors. So sometimes when you are installing applications, they will give you an option to initialize it with the default settings, or there will be an expert mode or advanced mode where you can manually choose the settings for the application. So those settings need to be initialized. If you choose the default settings and just click next, next, next and proceed on like that, all the default values are loaded. But if you choose the advanced option and you personally select some values, whereas you leave the others blank, it initializes those values provided by you, as well as the values that are not provided by you are automatically initialized to the default settings. Okay. Now let's just quickly take a look at the differences between a constructor and method. We have already discussed this, but let's see in the form of a table. So on the left hand side we have constructors, on the right hand side we have methods. So what are the differences? We're just making a quick summary of the differences and then we'll end our class here. So what are the differences? A constructor is used to initialize the state of an object, as you know. A constructor is used to initialize the state of an object. Here state refers to the instance variables. So in the object oriented programming concept, variables are In a class, variables are referred to as the state of an object, whereas the methods are generally referred to as the behavior of an object. How an object behaves is defined by the methods in the class, and the state of an object is defined by the class variables. So if you take a real world example of an object, let's say I'm talking about a car. So the color of a car is so the color of a car might define the state in which the car is. Okay. So whether it is green, red, or something else. So it defines a state, as in how the car looks. It's a state in which the car presents itself to you. So that is basically stored in a variable. So variables store the state of the object car. It could be the color, it could be anything else. It could be whether the car has a spoiler or not, whether the car has a vinyl or not. So those could be the states, various states of the car. Those are stored in variables, the values. And the behavior of a car, such that let's say gear change or braking, as you may say. So braking is an action performed by the car. So it's defined in the form of an it's defined in the form of a method. So braking will have certain actions involved with it. Those actions are defined by methods. So methods correspond to the behavior of an object, how an object behaves, like how the car behaves on pressing the brake pedal. So it will come to a stop. That is the behavior that has been defined in the method. So if you model a car object in programming, so the behavior or the actions that are performed by the car will be represented by the methods, and the state of the car, as in how it looks, how big is it, and other things like that will be um, stated by the variables. So variables are called the state of an object. Constructor basically initializes the variables. Why? That's why it's called, it says it like this here: constructor is used to initialize the state of an object, which means it basically initializes the variables of the object. And a method is used to expose the behavior of an object. So a method is used to expose the behavior of an object. So the variables define the state of the object, the methods define the behavior of an object. That is what the first difference is. A constructor initializes the state of an object, whereas a method is used to expose the behavior of an object, as in how the object behaves on performing a certain action. So how it will do it, that is defined by the method. How to perform an action. A constructor, so the second difference is the constructor must not have a return type. So a constructor must not have a return type, whereas a method must have a return type, at least void. So a method must always have a return type. A constructor must not have a return type, a method must have a return type. Second difference. The third difference, a constructor is invoked implicitly, which means It is invoked by default whenever you create an object. It's in the very definition of creating an object. So without invoking a constructor, you cannot create an object. Therefore, the very definition of how to create an object contains the invocation to a constructor. So a constructor is invoked implicitly, which means it does not need an object or something else to be called or invoked. It is invoked by default whenever you create an object. Whereas a method must be a method is invoked explicitly. So a method is not invoked by default. A method is invoked explicitly. Implicitly basically means automatically. Explicitly means manually. Just to remember it in an easier way, the word implicitly means automatically. The word explicitly means you have to do something manually. As in, a method must be called manually. If the programmer does not call the method manually, then it is not called. Whereas in case of a constructor, you just simply need to define an object and the constructor is called automatically. So that is the third difference. The fourth difference is the Java compiler provides a default constructor even if you don't write one on your own. If you rather if if a class does not have one, so the Java compiler provides a default constructor if a class does not have one. Whereas no default method or no such method is provided by the compiler on its own. So in case your class is missing a constructor, the compiler will provide you with a default constructor. But in case your class is missing methods, the compiler will not provide any such method on its own. And the fifth and final difference is the constructor name must always be the same as the class name. The constructor name must always be the same as the class name, whereas the name of a method may or may not be the same as the class name. So the name of a method may or may not be same as the class name, but for a constructor, um, it's a hard and fast rule to have its name as same as that of the class name. So these are the five basic differences, or the five differences between a constructor and a method in Java. So remember all these differences, and there's also something called a copy constructor. There's a concept, but Java does not support a copy constructor. So there's no point in talking about a copy constructor. Now, just a few more things before we finally end the class. So the first thing is, so these are just basically questions that they might ask you. So the first question is, do constructors return any value? So these are like trick questions. Do constructors return any value? Now, the very first answer that will come to your mind is, since constructors do not have a return type, therefore, no, it does not return any value. Right? That's the first thing that comes to your mind. But you will be wrong if you say that a constructor does not return any value. Although it does not have a return type, it's not permitted to have a return type. It does return a value. So the answer is yes, it returns the class instance or the object that call the constructor. So constructors do not have a return type. So if you do not actually know the answer, you would think that constructors do not return any value, but that is not the case. Constructors do return values. Although they are not permitted to have a return type, they do return values. And that value is nothing but the class instance or the object that called the constructor. So why is it this way? You do not need to know. Just know if they ask you if constructors do return any values. Yeah, they do. Constructors return the class instance. So that should be your answer. If you say no, the constructor does not return any value, you'll get a 0, because constructors do return values, and that value is nothing but the class instance or the object that call the constructor. So that's the first trick question. Now let us take a look at one more question. Can constructors perform other types of operations apart from initialization? So there is one more trick question for you. So when we studied constructors, we only studied that constructors are only used to initialize class variables. That is true. The in the less advanced stages or less advanced programming, as you guys normally do. So constructors used by you will always be used to initialize variables. But there are certain other operations that can be performed using constructors. So so inside the definition, or when you declare a constructor inside the curly braces, you almost often only initialize the variables, the instance variables, and you do nothing apart from that. But you can do other things as well, just like you can do many things inside a method, not just initializing but many other things inside a method. Similarly, inside a constructor also you can, inside a constructor, remember, we are talking about inside the definition of a constructor. Okay, where you are declaring, when you are declaring the constructor in a class, you'll just have lines that initialize the variables, but apart from that you can also have these. So the first thing that you can do inside a constructor is create an object. So you normally create an object in the main function, but you can also create objects inside a constructor. So object creation can be done inside a constructor. Starting a thread, this is obviously something that you do not know as of now, but just to let you know what can be done. You can call a method inside a constructor, calling a method. So let's say you have a method that is defined in the class. You can call that method from inside the constructor. Let's say the input method. So instead of calling the input method in the main function, you can directly call the input method inside the constructor. So once the object is created, the input method is automatically called from inside the constructor. You could do it in that way. So the statements that are allowed inside a constructor is not limited to the initialization statements, where you just initialize the instance variables to the parameters or default values. Apart from that, you can also create a new object inside the constructor itself. You can also start a thread. You do not need to know what do you mean by starting a thread, but it can be done. And you can also call a method inside the constructor. Let's say you have a method defined in a class, it could be any method. You could call that method inside a constructor. So inside a constructor, you can just not only initialize variables or instance variables, you can do these as follows. And you can do other things as well. So it's not just limited to these three. You can do other things as well. Anything that you can do inside a method can also be done inside a constructor. So inside a method, you can create an object, you can start a thread, you can call another method, and you can do other stuff as well. So inside a constructor too, you can do these kinds of things, not just initializing variables, but also these things that you can also just to remember it in a more easier way. Think about all the things that you can do inside a method. If you define a method, there are certain things that you can do inside a method. Initialization is one of them, but other than that, you can do certain other things. Just like inside main method, we can create an object. We can call a different method from inside a method. Similarly, those are things that can also be done from inside a constructor itself. Inside a constructor, it's not just initialization statements, but also these. Also the things that you can do from inside a method. Now let's move on to the next question. So this is a general knowledge type question. So is there a constructor class in Java? So does Java have a class defined that um, works with constructor? So is there a constructor class in Java? What do you think the answer should be? Most definitely yes. Java does contain a class called constructor that has certain functions that can be used. Let's not go into the details, but it does have a class. It does have a constructor class defined. Just like the string class, the character class, there's also a class for constructors, or the constructor class as we may call it. There's one last question before we end our class today. So what is the purpose of the constructor class? If you might be wondering. So why did we define a constructor class in Java? Just so these are just general knowledge questions. So what is uh, the purpose of the constructor class? Well, the constructor class can be used to get the internal information of a constructor. The constructor class can be used to get internal information in a constructor, or rather of a constructor in a class. So the constructor class can be used to get internal information about a constructor defined in a class. Where is this constructor class located? The constructor class is located in a particular package in the which is the java.lang.reflect package. So that is where the constructor class is defined, the java.lang.reflect package. They might not ask you the last two questions, but just so you know, there's also a class called there's also a constructor class that is defined in Java, and that constructor class is used to get internal information of a constructor defined in a class. So you could get details, internal details. So it doesn't matter what those details are, but you can get certain details of a constructor that has been defined in a class using the constructor class. And the constructor class is located in the java.lang.reflect package. So that's all for today's class. I hope you have understood the concept of constructors. So you need to remember the rules, the differences between a constructor and a method, the types of constructors, as well as overloaded constructors and how they are differentiated. So those are the things that they might ask you questions from.